Hello, ladies and gentlemen. I hope you're all doing well. You're feeling fine. You're ready to start our second last Cayley 2018 contest question. We've got question 24, and that's what we're going to be taking a look at here. So, question 24. There are more than 1 million ways in which n identical black socks and 2n identical gold socks can be arranged in a row, so that there is at least 2 gold socks between any 2 black socks. Okay. The sum of the digits of the smallest possible value of n is. Alright. So, So based on n, we can figure out the number of ways. So one thing we might try and do is look at a small case, like 2 black socks and then 4 gold socks, 3 black socks, 6 gold socks, and things like that. Now, the word identical here is striking me as very interesting, because what we're really looking at is just black socks, not this black sock and this black sock as though they're different, but just black socks. So you can't tell them apart. So what we're really interested in here is arranging them in a line or a row, and all we really want is, okay, a black one goes here, a gold one goes here, a gold one goes here, a gold one goes here, and then a black one goes here, and a gold one, and so on. And it just needs to satisfy the condition. So, alright, so we need at least 2 gold socks between any 2 black socks. So at bare minimum, it has to go black, gold, gold, black, gold, gold, black, gold, gold. So, I mean, that's definitely guaranteed, and we could see that if we worked on smaller cases, but you must, so hold on, let's say, first let's satisfy the minimum criterion. So I'll use B for black and G for gold. So black, gold, gold, black, gold, gold, black, gold, gold. Are we going to have enough? So it's going to keep going. Black, gold, gold, black, gold, gold, black. So that would be 1 million black socks have to be put down, and then we've got 2 million gold socks. So in theory, this works. Is there anything even left over? Yeah, there has to be. Otherwise, there'd only be one way. So we have one group of black, gold, gold, and that accounts for 1 black and 2 gold. We have another one, another one, another one, and we keep going. So this turns into... Oh, it's not a million. What am I talking about? It's n. So this is n minus 1 blacks and 2n minus 2 golds. And then we have one more black here. So that gets me n blacks, and switch back to the black color here. So n blacks have been placed, 2n minus 2 golds have been placed. So this leaves 2 golds left. So where can these golds go, is the question. This structure has to be here, but then we could come along and, if we look at a smaller case, you know, here's 3 blacks, and we've got 2 golds left over. We could take a gold sock and put it in here. And then we'd have black, gold, 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 black, gold, gold, black, and things like that. And that will be guaranteed to satisfy the condition. In fact, no matter where we stick this black, or this gold, it could go there, and we could put the other one down here at the end, or heck, both of them could go in here, and then we'd have black, gold, 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 black, gold, gold, black. So what could happen? So in our string, we have, okay, so we could place a gold before the first black. Or in any of these other groups, or after the last black. So as we said, there are n minus 1 of... Actually, let's color code it just to be very clear. So n minus 1 of these spots. That another gold or 2 could be shoved. And then we'll use pink on the end. There's 2 of these. So for a total of n plus 1 places to put the golds. The remaining two gold socks. Okay. So the question is, I guess, do they go together or do they go separate? So both are placed together. So I've got 2 golds and they need to be placed. Now, you might say, well, if I want to put them here, do they go in between these 2 gold socks before the first one? That's sort of what I'm getting at when it comes to the identical. It doesn't matter. What matters is black and then how many golds. Black and then how many golds. Black and then how many golds. That's what we get to choose, is how many golds in between the 2 blacks. Now, we have to have 2 golds in between 2 blacks. This forces us to have the string that we constructed on that first page, and we've got 2 golds to place, and now I'm saying we're going to place them together. So at the end of this, we'll either have 2 golds at the start of our line, 2 golds at the end, or one of the groups will have 4 gold socks. And so we have n plus 1 places to choose from, so each one is its own separate choice. And once we've chosen it, that's done. So we get n plus 1 places to choose. N plus 1 different strings. Strings or words or lists or lineups or rows, whatever you want to say. Alright, our other case is placed separately. So that means each gold is separate, and so I can't say, well, here I'll choose to put 1 gold in here, and then the next gold I'll pick, and then somehow I manage to put it back in here, because that's already covered by the previous work. So we've got n plus 1 places to pick. Need to choose 2 of them. Okay? Now, depending on how comfortable you are with counting problems and choose notation, you might say, well, up here we had n plus 1 and we need to choose 1 place, binomial notation. So down here, n plus 1 and we need to choose 2 places. You might be comfortable with that. Or you might say something to the effect of, well, we've got n plus 1 places to pick to be the first place. So, you know, we get n plus 1 spots, and then we've got n remaining spots. You know, once I've decided that this is going to get a gold sock, then I've got n remaining ones other than that one to place the other gold sock. But in doing so, if I were to come along and say, okay, I'll choose this, put a gold sock there, and then I choose this one to put a gold sock there, the end result is the same as if I said, I'll choose this one first, and then this one here. So what we're doing is we're really counting 2 things, or counting something, the same thing, but twice in 2 different ways, so we divide by 2. Okay? And this leads to different strings. Okay, so this gives me an expression. We've got n plus 1 plus n plus 1 times n over 2 ways to arrange our socks. Combining that into a single expression, we'll have n plus 1 times n plus 2 over 2 ways, and we need this to be greater than 1 million. Okay, so n plus 1 times n plus 2 needs to be greater than 2 million. Roughly, I would expect well, no, I guarantee this fact, but roughly this is sort of acting like n plus 1 squared over here. I know it's not. It's slightly more because of the n plus 2. So here's what we're going to do. We're just going to square root both sides, and you're going to roughly get n plus 1 on the one side. And so the square root of 2 million is 1414.2. So n plus 1, which has to be an integer, should be 1414. N's got to be 1413. And so what do they want? They just want 1413? They want the sum of the digits, so 1 plus 4 is 5, plus 1 is 6, plus 3 is 9. There we go. So 9 is going to be our final answer. And so we'll bubble in A. If you want to, just while we've made it this far, just to double check, especially if you're uncomfortable with me doing this step, plug in 1413 into this expression up here. And I'll even grab my calculator and do that. 1413 plus 1 times 1413 plus 2. Divide that by 2. And I get 405. To make sure this is the smallest, try the same thing with 1412. And you'll see, oh, that isn't more than a million. Or if it is, then I need to reevaluate what I've done here and reassess and try and go smaller. But the fact that we hit 1,405,000 makes me think that we're really, really close. So we'll do 1413 times 1414, divide that by 2, and yep, we're just under a million with 998,991. So, yep, answer of A, and we're looking great. So we are all ready to go for question number 25, the last question on the contest. I will see you for that in the next video. Until then, have yourself a wonderful day, and take care.